Hello, I'm Rob Hirschfeld, CEO and co-founder of RackN, and this is a training guide for Digital Rebar 4.8 Resource Management Abstractions. Specifically, we're going to walk through how to set up Digital Rebar in Amazon so that you can walk through and do your own play with cloud brokers, clusters, and machines. This general lesson could be applied to any of the clouds. We focused on Amazon because it's the most popular. And you can follow along using the Digital Rebar install documentation. So from the production install guide, we actually have a specific cloud and infrastructure install steps. In this case, we're going to be working from Amazon. I'm using US West 2, where the defaults for Digital Rebar are structured. If you use a different zone, that's perfectly fine. Just remember, you will need to update the region and the AMIs that the system uses by default. So here we're going to start a simple machine. We're going to use the Ubuntu server 2004. We test on Ubuntu and CentOS most heavily, so I'm going to recommend you work with one of those. And for this system, we're really trying to do a very simple demo. T2 Micro is sufficient, obviously not for production, but for a simple demo where you're doing some cloud work, it does work very well. Our configuration for this is pretty straightforward. We do want to use defaults, but I'm going to allow us to bootstrap the system automatically. And to do that, what I've added is a couple of small pieces. One is I'm using our standard install script with the addition of the IP address that we are getting from the public system. This demo will work perfectly well in one region without that addition, and I'm making sure that I'm pulling in the tip version of the software. Storage that we have is perfectly normal. I do like to add in a name so that we can identify the system. V4.8 training is going to be perfect. One thing that you will need to do is make sure that you have a security group that matches Digital Rebar's interfaces. As an absolute minimum, you need to open port 8092 so that you can access the server. I also suggest opening port 8091 and 8090 are two provisioning APIs. Those are helpful if you need to do external provisioning or multi-internet, across the internet provisioning. Everything should be just fine here. I'm going to choose my key and go ahead and launch the instance. In doing this process, let's see. What you can see is that I'm going through and just basically building a simple system. The addition of the curl install process means that it will automatically provision and bring up the machines. That process usually takes about 30 seconds, and so we will check back once that's been built. So let's check on our instance. We have an IP address. See, if we open it, what we really need to do is go to the 8092, so our actual port. Now, because we've not built a certificate for this, we're going to go ahead and need to accept the self-signed certificate, perfectly normal. This process is going to bring me, take my endpoint and then automatically direct me to the RackN UX. For this feature, I'm going to recommend that you use the tip UX. So we maintain a stable UX called Portal and a development UX called Tip, where we show off the latest features. The resource broker and cluster API components for Digital Rebar 4.8 are in tech preview, which means we are continuing to build applications and cluster capabilities on top of them in this release. And so everything you do with this, it is something that I'd recommend you pull in the latest code, the tip code, to make sure that you're getting the very latest components. Rocket Skates and Rocket Skates is our user password, which you can see the tip for here. I'm going to go ahead and let the system log in. I do need to be able to upload my license. I've already created a license, so I'm going to simply upload mine. In your process, you would fill in that screen with your information. We will not contact you, bug you, or trouble you at all. Since I already had a license, I've uploaded it, but I have not registered this endpoint yet, so I need to go ahead and make sure that endpoint is registered. on that license. So everything looks good for that. And now the system is good to go. What you'll see is that we've already gotten our bootstrapping system. That has run through our complete bootstrapping process. So our bootstrap came in. I can check on the results for that. And you can see all of the work that was done to bootstrap the system. This includes building and installing the container backend that we call context that enables these new processes to work. It's also created 2 default resource brokers for me. The context broker, which allows us to create machines in contexts for testing, and the pool broker, which would be used if we had existing infrastructures and we wanted to use our pool system to check in or check out machines as our resource group. We're going to create cloud brokers in this case, but it's useful to understand that those clusters already exist. And I like to verify that my system is working by actually creating a couple of a cluster using the container system. So I can choose the context broker for that. I can identify a couple of machines. I can go ahead and start that process going. And what you'll see is it's already doing what it needs to do. It's very fast in this case. The context broker is already completed, and the machines here are built and now going through their own infrastructure pipelines. And what you'll notice here is that the system does build and run an infrastructure pipeline for all of the systems, even the ones in containers. We run them as if they are doing a regular provisioning step. So the universal runbook would allow me to run an Ansible or additional configuration step in an ad hoc way for the systems as I bring them up. I can go back to that cluster and do exactly what I would expect by scaling it up or down, starting that workflow. And what you'll see is that as we build those systems, they're going to very quickly build through and add the machines that I wanted to have in the system. So that's excellent. We now have the basics of a working system installed in Amazon in just a couple of minutes. Now, one thing that I would remind you here is that RackN is not a SaaS. So this is your digital rebar instance. It is running under your control. The Amazon credentials that we're about to put in are going into your infrastructure. RackN does not see them. We do not have access to them. This is a completely standalone infrastructure for you and your use only. The use of the portal here is simply an easier way for you to download the latest UX and get patches. We do have enterprise-grade customers that choose to run the UX themselves, and that can be hosted from their digital rebar endpoints. So here, what we really want to be able to do is add in another resource broker. Here, since we're doing an Amazon demo, we'll create one for Amazon. You'll see that we have predefined resource definitions for many different clouds. Each one is going to provide you with a custom view of what that's doing. And this is going to be a US West broker, so I'm going to call it US West. I have to provide my credentials in the system. Once again, these are not going to RackN. These are only in your local system. And the region here will be US West. It's going to use T2 Micro. And I am using this AMI, which is the Amazon Linux for US West. I could add additional information. This should be sufficient for what we're doing. And I'm going to give this a purple color and let it be, instead of AWS, we will give it a, not an alarm, that looks scary, but idea light bulb icon. So when we say go here, it's going to immediately do nothing. It's the broker. It just has the credentials, the parameters that we need. So if I'm jumping into the profile, I can see this is what we've defined. I can do one additional thing that's sort of handy. If I add in the parameter for the Terraform debugging, this will allow me to see the Terraform plan. Normally we throw them away. There's sensitive information in the plan, so we don't keep them. They're regenerated dynamically each time, but from a debugging perspective, it can be very helpful to see the plan that's put together, because Digital Rebar builds the plans out of multiple parts, and if you want to see what the final plan was, this is a way to store it and keep it. So now that we've built our broker, we can jump over to the clusters and go ahead and use that cluster. We're going to call it cluster 1. I'm going to choose US West as my target site. I will give it a few machines. Make this purple also. Same icon. That looks great. And when I start here, you'll notice that that cluster immediately begins running the cluster provision infrastructure pipeline. That means that the system here is going through a cluster lifecycle. It's not actually creating the machines. It's not the cluster's job to do that. It's contacting the broker with a list of machines that it wants created. If I jump over to the resource broker now, what you'll see is here is my US West broker. It's running Terraform. I can actually see it running Terraform, and it's telling me exactly what it's doing. Here you can see it's creating these machines. Part of what we've done with Terraform and the way we've integrated to Terraform behind the scenes is we actually detect machine creates and destroys, and the system, as it's building machines, will also register them in Digital Rebar. And we will see those machines added into the system even before they are fully provisioned in the appropriate cloud. So you can see them coming in. At this point, this is a stub machine. If I come over in the parameter, you'll notice I know the idea of the system, I know what cloud provider it's going to use. That allows the bootstrapping process that's going to connect in. So as those machines come online, they will register with Digital Rebar and they will start their own infrastructure pipelines. This is a really significant point because those infrastructure pipelines include additional post-provisioning steps that will happen automatically. So the system will hook in and then start its own workflow. And we will be able to see that happening in just a second. If I jump over to AWS, we can also see that these machines are all created now. And if I come back in just a moment, as those machines have been initialized, they will also run their own workflows here. So the system has started populating as it's building through that workflow. And what you can see is it's literally coming in and getting information as it's running this pipeline. So let me jump over here. These are the pipelines it's running. It's actually started the runbook process from discovery, just like the containers. One of the things we're doing is normalizing the automation pipelines in every system. So you can build automation pipelines, infrastructure pipelines that run across clouds in a consistent, normalized way. We've also decoupled the operations. You can have a team that focuses on the infrastructure pipelines for individual machines, one's for clusters, one's for resource management, and allow teams to manage and control the Terraform workflows. So if I was to create a secondary cluster and identify US West again, I could build a standalone cluster that had its own Terraform plan, its own state file, and I'll show you exactly what that looks like. So if I go back to cluster 1, what you'll see is that we have stored we've stored the Terraform state file for that cluster. This new cluster spinning up will have its own state file that will be associated with that cluster. We've also, as I told you before, captured the full Terraform plan that was executed. So that means that you can see exactly how the system was built, what tags, instances, resources were defined, and it is perfectly normal for you to be able to override and extend this with your own resource definitions and pull in data from the Digital Rebar cluster as those templates get built. So actually a very simple process, and it's all infrastructure as code. So you can manage all of these templates and the build processes in a source-controlled way. Let's go ahead and build that second Amazon cluster. So I wanted to create a cluster here for US East. I need my keys again. And one of the things that's important to understand here as I build this is that if you had different resource brokers with different credentials, you can actually manage this process. Since resource brokers are decoupled from the clusters, you don't have to give your credentials to everybody else. You can allow the resource brokers to be an abstraction that means that the right people control the right information within the system. I'm going to go ahead, because US East has different AMIs, even if it's the same operating system, we have to respect that and build those in. Here we can use a nice green and pick a different icon, ticket, save and run. So in this process now I've built a broker for US East, and if I was to build my third cluster here, cluster 3, I could pick US East and run that cluster. And that cluster now is going through the exact same build process. I can look in the resource brokers and you'll notice that they are now, US West is already complete, US East is now going through the process. The consistency and repeatability of what we've built is really unmatched in industry. The very repeatable infrastructure pipeline systems that we've built with Digital Rebar allow you to control and extend these pipelines in standard ways and allow them to be repeated and reused across your organization. So our clusters are building here. Our machine collection continues to grow across our infrastructures. If I check in with Amazon, what you'll see is all of the different machines that we have. The tags are getting set. If I come into US East, you will see those systems probably already coming through. They are, and they're in a pending state. And even though they're pending here, they will start appearing in Digital Rebar as soon as Terraform has established that they get handed off from Amazon. So this process allows the integration of different sites, different clouds, different regions back into an incredibly consistent control and automation process that gives you the ability to have cluster lifecycle controls, separate out resource brokers, and then reuse your Terraform in consistent ways. One of the things that I find really powerful here is that even as you have people using clusters, it is possible for the Terraform experts on your team to go back and look at exactly what's been happening. So we can look at this process, see our Terraform plans and capabilities, and then look at exactly what happened if something went wrong, or make sure that if things are going right, that what they expected to happen is happening. The other thing that's really helpful here is because we are tracking the resources for each system, if I want to go back into a cluster and take cluster 1 and basically empty that cluster and drain it, all I have to do is set it down to 0, and that will allow the cluster to remove all of the resources. Now, I can also, if I just was deleting this cluster, we don't just destroy the data, we actually run it through a cleanup process, and in that cleanup process, it will go through and tear down the infrastructure, basically doing a Terraform destroy. Now, I do want to point out, the system is not limited to Terraform. We are using Terraform as part of our default workflows. But if you have an API call, a CLI call, or something that you need to add into these processes, it is trivial to extend and add a task to do exactly that. And so the system allows you to take advantage of a tool like Terraform or Ansible as part of your workflows. But in places where you need to extend or change or integrate into your CI/CD system or other inventory management system or security ServiceNow or some type of workflow, you can come back into those systems and integrate those easily into these infrastructure pipelines at the cluster, machine, or resource broker levels. So with that, we've given a pretty high-level overview of how these work. We've walked you through the process so that you can create these yourself. It is actually very easy to do exactly the steps that I've taken, build a resource broker, especially in the same Amazon region, and then build and run cloud infrastructure using exactly the processes that I have. Now, we do want to talk to you, and we're excited to hear about your experience and answer questions and have a meeting with you to talk about how this works behind the scenes, how you can use it for your team, and also get feedback from you about what you think we did right, what you would like to see us improve on. Please visit us at rackn.com and become part of our community. We're very excited about the new resource management abstractions that are in Digital Rebar 4.8, and we want to make that part of your experience. Thank you.